All right, so I'm kind of, for each of these that we do, we're going to kind of go through the thought process. What's the easiest way potentially to solve, the next easiest way, and so on. So this one we would look at and we can say, can I solve this using equal bases? And we're going to say no, because I cannot see a way to easily write 250 as 1.87 to a power. Can we rewrite as a log? Yes, we can, right? We can go and say, okay, 250 is equal to 1.87x, right? And then we can rewrite this. We can say log base 1.87. So what power do I have to raise 1.87 to get 250, right? So this would be 1.87 to the x equals 250. And that's a number. Log base 1.87 of 250 equals x. That's an okay answer, okay? It is really not the best answer because nobody likes, we really want to keep this, if at all possible, in natural log or common log. So it's not really the best option. Okay, so if that's not the best option, what is? Well, it's going to be that mental trick from earlier, which is to take the log of both sides. So we're going to go back to this 250 equals 1.87 to the x. We're going to take the log of both sides. Your favorite log, common log or natural log, it doesn't matter, as long as you do the same thing to both sides, right? And then we're going to use our power rule, which says, hey, I can bring that x out front, and I still got log 250 on the other side, and then remembering that log of 1.87 is just a number we can divide through by both sides, by that on both sides. So I've got log 250 over log 1.87. Now you will notice, hopefully, that is our prior answer, but with the change of base formula applied, the log of the argument over the log of the base. So which is why I said you really don't have to remember the change of base formula. It's pretty easy to get to. All right. So we've got another one, right? Equal bases, absolutely not. Can we rewrite as a log? No, because we have two logs. Can we log both sides? Yes. Okay, and this does get a little tricky, right? So, this time I'm going to take natural log. What the heck? ln of 5 to the x plus 2 equals ln 4 to the 1 minus x. Then we're going to use our power rule or power property on both sides. So I'm going to bring that x plus 2 down around front. Okay. And then here is, to me, this feels like when we were finding the inverse function of a rational function. So we're going to say, hey, ln of 5 is just a number. ln of 4 is just a number. So I can distribute and collect like terms, collect my terms with x's, collect my terms that are all numbers, and solve for x. All right, so I'm going to have x ln 5 plus 2 ln 5 equals ln 4 minus x ln 4. And we are going to put our terms with x's on one side and our terms with x's without x's on the other side. So we will have x ln 5. I'm going to add x ln 4 to both sides. I'm going to subtract 2 ln 5 from both sides. And then you say, oh, look, on the right-hand side, I got an x that I can factor out. And then I can finally solve for x. So I got ln 4 minus 2 ln 5 over ln 5 plus ln 4. Now, if you got it to there, I'd be pretty happy. But what we can do a little bit more, we can say, well, ln 4 plus ln 5, that is ln of 20, right? And ln 4 minus ln of 2 ln of 5, that would be ln of 5 squared. And now I have a quotient rule that I can apply there, right? So this would be ln 4 over 25 over ln of 20. Is that any better? I don't know. So honestly, I would take any of those answers. I'd be happy for you to get here, and I'd be really happy if you got there. All right. So what's up next? This one's a little weird, but there is one in your homework, so we're going to do that next.